I was on my knees in the dust of my workshop, picking with a chisel at something I had considered my pride and joy just 9 years ago. 9 years. In a human life, that's a decent stretch of time, but for an oak bench assembled according to all the canons of modern high-end joinery, it should have been nothing but a heartbeat. I remembered the day I finished it like it was yesterday. Select, kiln-dried white oak, crisp mortise and tenon joints, expensive German D3 rated PVA glue, and 3 coats of yacht varnish that gleamed in the sun like a fresh mirror. I was certain this piece would outlive my grandchildren. But the reality under my hand didn't smell like fresh wood shavings. It smelled like wet chalk and failure. When I flipped the bench over, it had spent those years on an open terrace, enduring the biting winds, the drenching rains, and those brutal February thaws. I saw a catastrophe. In the 2 main structural nodes where the tenon meets the mortise, the glue had transformed into a white, crumbly substance. It hadn't just delaminated, it had degraded into something unrecognizable. I slid the edge of my chisel under it, and it flaked away like dry skin, revealing the absolutely clean, naked surface of the wood. There was no adhesion left, no bond, no soul. A polymer that promised permanent waterproofing on the label had simply surrendered, becoming nothing more than alien debris inside the living fiber of the oak. 5 years ago, I had noticed the first signs of trouble and written it off as a failure of PVA. I figured polyvinyl acetate was, after all, just household chemistry. So I stripped it back and re-glued everything with polyurethane, the stuff that foams up, penetrates the pores, and is touted as a death grip for outdoor work. 3 years passed, and the bench started to wobble again. When I finally pulled the joint apart today, I saw a different picture, but one no less pathetic. The foamed mass had become as brittle as sun-baked clay. It was covered in a microscopic network of cracks. Every time someone sat on that bench, those cracks grew until the joint turned into a glorified rattle. It was at that exact moment, staring at the dust on my workshop floor, that I asked myself the question I should have asked in the first year of my apprenticeship. Why did I ever decide that glue was a mandatory condition for strength? Why are we, as modern makers, so pathologically afraid to trust the geometry of the wood itself? I found the answer 2 weeks later, standing in a drenching downpour at the Museum of Wooden Architecture in Suzdal. Before me stood a simple peasant house, an izba from the 15th century. It had stood for 200 years under the open sky, 2 centuries of soaking and drying, of deep freezes and sudden thaws. Pine and spruce, which according to every modern textbook should have rotted away before the First World War even started, were still there. The log structure stood firm, the porch didn't creak, the rafters held the roof, and there wasn't a single gram of glue in the entire assembly. I ran my palm over the joint where 2 logs met in a corner notch. The wood had weathered to a silvery, bone-like sheen over the 100-year mark, covered in deep checks and cracks, yet the joint itself was monolithic. You couldn't have slipped a razor blade between those timbers if your life depended on it. This massive, heavy structure wasn't held together by chemical bonds that break down under UV light and moisture. It was held by pure physics and geometry. One element blocked the next, the second pressed down on the third. It was a system that worked not in spite of the material's nature, but because of it. The museum caretaker, an old man with hands that looked like the gnarled roots of an ancient oak, watched me. He told me that when these houses were moved from their original villages, the restoration carpenters marked every log, and when they reassembled them, joints that were 150 years old slid into one another with the exact same friction fit they had when the masters first shaped them with axes. The wood had shrunk, it had changed in volume, but the precision of the fit remained. Geometry doesn't age. It doesn't oxidize. It doesn't wash away with water, and it doesn't crumble into dust. That day I realized that any glue in woodworking is, at its core, a prosthetic. It's a crutch we lean on to support a weak connection. We use glue to compensate for a poor fit, a lack of engineering foresight, or just plain laziness. Glue is the weakest link in any build because it is always a mediator between two surfaces. And in the world of structural integrity, the mediators are the first to leave the stage when the real trials begin. In my 20 years in the craft, I've tried it all. Two different classes of PVA, polyurethanes, epoxy resins, hide glue, and fish glue. And today I can tell you with total conviction, if you want to build something that lasts centuries, you have to build it as if glue doesn't exist. You have to force the shape of the parts to do the work you usually delegate to a bottle from the hardware store. The architecture of silence. When I walk through the gates of the Suzdal Museum, past the Church of the Transfiguration, a massive structure hewn in 1756, I wasn't looking at it like a tourist. I was looking at it as an engineer and a man who has spent 2 decades fighting with oak and walnut. The Vladimir region of Russia is a place of brutal, capricious weather. The humidity here doesn't just drift, it slams back and forth, from 30% in the bone-dry, crackling frosts of January to 90% in the unrelenting autumn rains. For a piece of wood, this is psychological warfare. The fibers are constantly swelling and contracting, creating internal stresses that can reach hundreds of pounds per square inch. In such an environment, any rigid chemical bond, any glue line, eventually becomes a zone of guaranteed structural failure. I stopped in front of a peasant house, an izba, that had been relocated from the village of Kozliatyevo. It was over 250 years old. Think about that for a second. 10 generations of humans have lived, worked, and passed away since those logs were first notched. Empires have risen and dissolved into history, yet these timbers were still holding on to each other with the grip of a drowning man. I leaned in close, my face inches from the silvered wood, examining the corner joins, what they call vobla, or joining with a remainder. My fingers, which are used to the precision of a digital caliper, were searching for the catch. I expected to find gaps big enough to slide my hand into. After all, pine and spruce should have shrunken significantly over 2 centuries. But the joints were tight. The wood had turned to stone, weathered and gray, yet the nodes were locked as if they had been cast in a single mold. It was right then that I understood the missing link. Those old masters, the carpenters who built these cathedrals and homes, using nothing but an axe and a Tesla, a specialized adze, possessed a fundamental engineering truth that we've traded away for the sake of speed. Their philosophy was simple. Wood is a living entity, and you cannot stop it from moving. If you try to hold wood still with a polymer, the wood will eventually win. It will tear itself apart, or it will tear the glue. The masters of the 18th century didn't fight the movement, they weaponized it. Their central principle was the mechanical blocking of degrees of freedom. Every single component of the house was designed so that its own weight and its specific geometric shape served to tighten the joint next to it. It was engineering magic. They used dovetail notches in logs, wedged tenons, and hidden teeth in floor beams. In this system, glue wasn't just unnecessary, it was a liability. Glue robs a structure of its micromobility, that tiny vital room to breathe that allows a building or a chair to expand and contract without self-destructing. I remembered reading through old craft guild regulations from the era. An apprentice carpenter might spend the first 3 years of his life just learning how to feel a fit. A master would test a student's work with a simple, brutal audit. He would strike the junction of 2 dry-fitted timbers with the butt of an axe. If the wood emitted a dull, solid thud, it was accepted. If the sound was sharp, hollow, or, God forbid, there was a rattle, the apprentice was told to start over from scratch. It wasn't about nostalgia or being traditional. They had access to glue. Bone glue and hide glue have been around since ancient Egypt. They were used in the Middle Ages for fine cabinetry and icons. But those masters knew better than to ever trust a chemical bond in a structural node exposed to the elements. They knew that chemistry betrays, but geometry is eternal. Today we live in the era of fast joinery. We're pressured to turn out a table or a cabinet in 48 hours. Modern PVA gives us a dangerous illusion of competence. It allows us to be sloppy. If a tenon is a 1/16th of an inch too loose, we don't fix the tenon, we just add more glue, assuming the gap-filling properties will save us. We ignore the layout mistakes because the squeeze-out hides the crime. But look at the mass-market furniture from 5 years ago. It's already destined for the landfill because it's held together by nothing but a chemical promise. Once that glue line degrades, and it will degrade, the piece loses its soul. When I returned to my own shop from Susdal, I looked at my collection of high-tech clamps and my shelves of proprietary resins, and I felt like a fraud. I realized my 20 years of experience was largely a history of fighting the material instead of collaborating with it. I decided to strip everything back to the basics. I picked up a block of oak, set aside the bottles with the fancy logos, and started relearning how to cut a joint that holds itself together by sheer force of will. The bridge between the 15th century and my modern workshop isn't about giving up power tools. It's about returning to engineering honesty. If your joint falls apart in your hands without glue, you haven't built a structure. You've just stuck two sticks together. Now, let's get our hands dirty. I'm not here to show you shop tricks. I'm here to show you the 4 nodes that currently hold my workshop together. Furniture and structures that haven't seen a drop of glue in 3 years and are tighter today than the day I finished them. If you're going to follow me on this, I need you to do one thing. Take your glue bottle and put it in a cabinet you don't plan on opening for a month. You won't need it. The first connection, the one I tell every woodworker to start with to understand the raw power of geometry, is the wedged through tenon. In the English tradition, we call it a wedged tenon. The old-timers I met in the East simply called it a locked tooth. This isn't your standard decorative wedge. It is a structural transformation. The concept is pure physics. A tenon passes through a mortise and is widened on the exit side so it physically cannot be pulled back through. It becomes a dovetail in reverse. When I cut this, I leave the tenon about 10 millimeters to 12 millimeters proud of the surface. Before I even think about assembly, I take a thin kerf back saw, something with about 14 to 16 TPI, and I make 2 vertical relief cuts in the end of the tenon. I stop the cut about 2/3 of the way down the depth of the mortise. Now the heart of the joint, the wedges. I never use the same wood for the wedges as I do for the tenon. If I'm working with white oak, I'll use black walnut or even Osage orange. You want something harder and more dimensionally stable. The angle is critical. I've found that a 5 to 7 degree taper is the sweet spot. If you go steeper, say 10 degrees, the wedge will want to spit back out at you during assembly. If you go too shallow, it won't exert enough lateral pressure to deform the fibers. When I drive those wedges in, I listen. You don't watch the gap, you listen for the crack. It's not a wood-splitting crack, but a high-pitched metallic tink as the fibers of the tenon are compressed against the walls of the mortise. In my shop, I ran a stress test. A 25 millimeter by 40 millimeter white oak tenon, double-wedged, held under a hydraulic jack. It withstood 4 tons of tension before the surrounding wood fibers began to shear. A modern PVA joint in the same configuration failed at exactly 2.1 tons because the glue line simply sheared away. The wedge doesn't just stick, it integrates. Second is the aristocrat of the timber frame, draw boring. This is what allows a house to stand for 3 centuries without a single nail. The concept is the offset hole. You drill a hole through the cheeks of your mortise, then you insert the tenon and mark the center of that hole. You pull the tenon out And here is the magic. You move your drill bit 1.5 millimeters to 2 millimeters closer to the shoulder of the tenon. When you drive a wooden pin, a nagel or peg, through those misaligned holes, the peg acts as a wedge-shaped lever. It pulls the tenon deep into the mortise with a force no parallel jaw clamp could ever hope to achieve. For the pins, I never use dowels from the hardware store. Those are sawn and the grain runs out the sides. I rive my pins. I take a straight grain billet of oak, split it with a froe into square sticks, and then drive them through a steel sizing plate to make them round. A riven pin has continuous grain from end to end. It's basically a wooden cable. When you drive a 12 millimeter riven oak pin through a 2 millimeter offset, the wood screams. It's a literal screech of compressed fibers. But once that pin is through, the joint is under constant, eternal tension. I've taken apart drawbore joints from the 1880s where the pin was bent into a permanent S shape. Even with the wood bone dry, the joint was so tight I had to drill the pin out to separate the timbers. The third technique is the tusk tenon, or the wedged scarf. This is for when you need a joint that you can actually tighten over time. I use this for the stretchers on my heavy workbenches. Instead of a permanent wedge, you have a large, removable tusk that passes through the protruding part of the tenon. The key here is the shoulder angle on the tusk, usually about 8 degrees. Every 2 or 3 years, as the seasons change and the wood inevitably shrinks, you don't reach for a screwdriver. You reach for a mallet. One tap on the tusk, and the entire 200-pound workbench becomes rock solid again. It's a living joint. Modern fasteners just strip the wood when they loosen. The tusk tenon uses the looseness to create a new, tighter bond. Fourth, and perhaps the most complex, is the scarf joint with folding wedges, often called the Jupiter joint or zaryad in the old Russian texts. This is how you turn 2 short beams into one long, unbreakable one. The ends of the beams are cut into a staircase pattern that interlocks, but they are designed with a rectangular window in the center. You insert 2 opposing wedges into that window. As you drive them toward each other, they force the teeth of the joint into each other. I first tried this when I was building a 12-foot garden trellis. I used 2 6-foot sections of cedar. Normally, you'd lap them and bolt them. But I cut a 300 millimeter long scarf with a central wedge. During a summer storm, a branch fell on that trellis. The cedar beam snapped in the middle of the wood, but the scarf joint didn't even budge. It was stronger than the tree itself. Why? Because the wedges create internal compression. Most modern joints fail in tension. The pieces pull apart. This joint turns pulling force into pushing force. The more you pull on the beam, the tighter the teeth bite. Finally, there is the fox wedge, or blind wedging. This is the no-return joint. It's for when the tenon doesn't go all the way through, but you want it to stay forever. You cut small slots in the end of the tenon and start small wedges into them, but you leave them sticking out. Then you drive the tenon into a blind mortise. As the wedges hit the bottom of the hole, they are driven into the tenon, flaring it out at the base of the hole where you can't see it. It's essentially a hidden anchor. I'll be honest with you, the first 3 times I tried a fox wedge, I failed. I made the wedges too long, and the tenon wouldn't seat all the way, leaving me with a 3 millimeter gap that I couldn't undo because you can't pull a fox wedge back out. It's a one-shot deal. But when you get it right, when the wedges are exactly 2 millimeters shorter than the depth of the mortise, the result is a piece of furniture that feels like it was carved from a single block of wood. No glue can match that level of mechanical certainty. Working this way changed the way I look at my lumber pile. I stopped looking for straight and flat and started looking for grain direction. If I'm making a drawbore pin, I need the grain to be perfectly straight for 150 millimeters. If I'm making a wedge, I look for the dense, slow-growth heartwood. When you work with glue, the wood is just a substrate, a surface for the chemical to grab. When you work without glue, the wood is the engine. You start to respect the species' unique properties. You use the elasticity of ash for your pins and the crushing strength of oak for your mortises. This is what I mean by collaborating with the material. You aren't forcing your will on it. You are asking the wood to use its own strengths to hold your vision together. It takes 3 times as long to lay out and cut these joints, but the first time you assemble a table and it stands perfectly rigid without a single clamp, you'll realize you haven't just built a table, you've built a legacy. When you stop reaching for the glue bottle, something shifts in your head. You stop being a gluer of parts and you start becoming a constructor. It's a fundamental change in the way you perceive the materials in your hands. Over my 20 years in the sawdust, I've realized that most of my early failures weren't because I didn't have the right tools, but because I was trapped in 4 patterns of thinking that are common in modern workshops. Habits that I had to unlearn to truly understand the masters. The first pattern is the glue as gap filler delusion. We've all done it. You cut a tenon, it's a bit loose, and you think, it's fine, the glue will take up the slack. But glue is not a structural material. It's a film, usually no more than 0.003 to 0.005 inches thick. When you use it to fill a 1/16 inch gap, you aren't creating a bond, you're creating a bridge of brittle plastic. Under the stress of someone sitting on a chair or the vibration of a machine, that plastic bridge shatters. I spent years fixing joints I'd cheated on, only to realize that a dry, perfect fit joint without a drop of glue is 10 times stronger than a sloppy one swimming in PVA. The second is the efficiency trap. We think traditional joinery is too slow because we measure time in minutes spent at the workbench. But we don't factor in the time spent waiting for glue to cure, often 2 to 24 hours where you can't touch the piece. With mechanical joints like a drawbore or a wedge tenon, the second the pin is driven, the joint is at 100% strength. You can move on to the next step immediately. When I look at my total shop time, building without glue is actually faster because I'm never waiting for a chemical reaction to finish. The third is the arrogance of the warden. For a long time, I viewed wood as a prisoner I had to lock down. I thought if I used enough glue and enough screws, I could force it to stay flat and still. I was wrong. Wood is a living, breathing hydraulic system. A white oak board can exert thousands of pounds of pressure as it expands 3% to 5% across its grain during a humid summer. If you glue it rigidly into a frame, the wood will literally tear its own fibers apart to move. The old masters weren't being quaint when they used sliding dovetails or peg joints. They were being engineers. They were building slip into the system so the piece could breathe without self-destructing. And the fourth is the marketing bias. We've been conditioned to believe that the latest chemical innovation from a lab in Germany or Ohio is superior to 500 years of trial and error. But those labs test their glues in ideal conditions, controlled humidity, perfectly clean surfaces, and static loads. A chair in a real house isn't in a lab. It's being dragged across a floor, it's having coffee spilled on it, and it's experiencing the dry heat of a radiator in December. The data of the Suzdal masters isn't on a spreadsheet. It's in the fact that their buildings are still standing after 250 years of real-world torture. Now, for the bonus I promised you, the living assembly trick I learned from Ivan Petrovich. He saw me struggling with a joint and told me that the strongest bond isn't made with a bottle, but with a moisture differential. Here's how it works. I take my pins and wedges, the active parts of the joint, and I keep them in a small kiln box, or even just on a warm radiator for 2 days before assembly. I drive their moisture content down to 6 or 8%. The main timbers, the passive parts, are kept at the ambient moisture of the shop, usually around 16 to 18%. When I drive that bone-dry peg into the slightly wetter timber, something incredible happens over the next 72 hours. The peg wants to be in equilibrium, so it begins to suck moisture out of the surrounding wood. As it does, it expands. Simultaneously, the wood surrounding the hole, losing its moisture to the peg, shrinks and tightens its grip. The two pieces of wood literally grow into one another. Ivan told me that back in the day, they would prepare their pins in the winter, drying them out in the biting dry cold, and then assemble the structures in the spring when the logs were full of sap. By the time autumn rolled around, the house had become a single, monolithic block of wood. I've tested this by trying to drive out a moisture-locked pin after 6 months. You can't do it. You have to drill it out. The fibers are so tightly interwoven that the boundary between the two pieces of wood effectively disappears. This is the higher math of the craft. It's about understanding that you are working with a biological material, not a dead one. When you finish your next project, I want you to try just one joint without glue. Cut one wedge tenon. Feel that dry, solid clack as the wood seats home. Look at the end grain where the wedge has blossomed the tenon into a permanent lock. In that moment, you'll realize that the glue bottle was just a safety blanket. True strength doesn't come from a tube. It comes from the sharpness of your chisel, the precision of your layout, and your willingness to trust the geometry of the tree. Build for your grandchildren, not for the next 5 years. Build so that when someone looks at your work in 100 years, they won't find a crumbly white powder in the joints. They'll find a master's signature in the way the wood still holds itself together. If you've stayed with me this far, you're the kind of maker who cares about what's under the varnish. In our next session, I'm going to take this philosophy to the extreme. I'm starting a new build, a small timber frame workshop where there won't be a single nail, a single screw, or a single drop of glue in the entire skeleton. Just wood, an axe, and a lot of patience. I'll see you in the workshop.